very, very warm welcome to you from Brest in Brittany here in France to this One Ocean Science Forum at the One Ocean Summit. I'm Victor Mallet from the Financial Times, and like a lot of you, I'm very passionate about the seas and oceans. I go under the sea to dive, I go in it to swim, and I go on it to sail boats. And of course, like everyone, I depend largely on ocean transport for many of the things I eat, drink and consume.
Je dépends aussi du transport maritime pour ce que je consomme, les aliments, etc. Vous allez beaucoup entendre parler de ce One Ocean, oui, un seul océan, car tout est lié. Et nous voudrions remercier l'Atelier des Capucins pour nous donner la possibilité d'utiliser leur nouveau musée maritime 70.8, parce que 70,8%, c'est un chiffre un peu emblématique qui représente la surface de la Terre couverte par les océans. Cet océan, ces océans qui sont surexploités, affectés par les comportements humains et dont nous n'avons découvert qu'une petite partie, et ces océans qui jouent un rôle tout à fait crucial dans le climat et les dérèglements climatiques. Nous allons donner la parole à des scientifiques du monde entier qui vont nous expliquer comment ils comprennent et font progresser la compréhension de l'océan et comment ils œuvrent pour limiter les effets de ce que d'aucuns appellent l'anthropocène. Je vais accueillir François Houllier, président directeur général de l'IFREMER, responsable de l'organisation de ce forum, et qui va ouvrir cette session. Merci Victor de cette présentation.
Je suis très heureux que nous soyons ici aujourd'hui à Brest pour ce deuxième forum que nous organisons.
Je suis ravi que nous organisions ce forum à Brest. Alors pourquoi avoir pris la décision d'organiser ce forum sur One Ocean Science, l'océan au cœur de la science? Eh bien parce que l'océan et le climat ont des interactions tout à fait critiques, non seulement pour les océans, mais aussi pour la planète dans son ensemble et pour l'humanité. Et très souvent, on les ignore, ces interactions. Si bien que pendant la préparation de la COP26, qui s'est tenue à Glasgow à l'automne dernier, l'idée a été de renforcer le message sur l'importance de l'interaction entre l'océan et le climat à l'avenir. Le deuxième objectif avec ce forum, c'est de souligner la diversité de ces interactions entre océan et climat en fonction des différents écosystèmes océaniques, parce qu'il y a plusieurs effets, répercussions sur le climat que nous voudrions illustrer. Illustrer les diversités d'interactions entre océan et climat. Alors, pour le faire, nous avons voulu mettre en lumière l'importance de la science, des connaissances qui sont déjà nombreuses et dont nous disposons, des solutions dont nous disposons également au sein de la communauté scientifique. Et tout simplement, ce que nous avons l'intention de faire aujourd'hui, c'est de montrer pourquoi cette science océanique est si essentielle pour lutter contre le changement climatique, pour avoir des effets sur lui. Et on va illustrer dans quelques secondes ce que est cette One Ocean Science. Et il y a quelque temps, le CNRS, l'IRD et la présidente de l'IRD est avec nous, à quelques mètres de nous, Valérie Verdier. Et donc, nous avons décidé d'organiser un aperçu des sciences océaniques sous la forme d'un tour du monde en réunissant 77 institutions au-delà d'IFREMER, de l'IRD, du CNRS, pour récupérer des vidéos et grâce à l'aide de la Ocean Climate Platform, One Ocean Science a pu prendre la mer pour se rendre à l'Ocean Action Day de la COP26, la journée d'action pour l'océan, et nous avons également eu le soutien de l'Agence spatiale européenne et de Thomas Pesquet, astronaute de l'Agence spatiale européenne, et donc une courte vidéo qui va vous présenter en quelque sorte les résultats de cette One Ocean Science que nous avons organisée. Enfin, dernier point, aujourd'hui, il me semble que cet outil numérique a rencontré un certain succès, et ce qu'il nous importe de faire aujourd'hui, c'est de capitaliser sur cette expérience menée l'automne dernier pour élargir le champ scientifique et aller au-delà des interactions entre océan et climat, mais aussi de nous intéresser à l'halieutique, à la pollution, et faire passer le message auprès de l'opinion publique, lui faire comprendre qu'il y a une communauté scientifique très active, très dynamique qui travaille sur ces questions. Alors, je rabâche un petit peu, mais c'est comme ça qu'on fixe les notions. La science autour des océans, les sciences océaniques sont importantes. Et on va regarder cette petite vidéo d'introduction.
Sayansi ya bahari ni ya umuhimu sana na tunapaswa kuiendeleza.
Per questo la ricerca non si può fermare. La sfida nelle scienze marine per affrontare i cambiamenti climatici si potrà vincere solo con misure e modelli di previsione sempre più affidabili.
It is very likely some of the oxygen you're breathing right now was produced by these tiny phytoplankton.
We're great producers of carbon dioxide by burning things or other processes, and these organisms are helping take that back into the oceans.
Our lives are intertwined. One way or another, we are the ocean. Listen, and let us be clear. We are the ocean.
Thank you, One Ocean Science, for raising awareness of the essential role of the ocean and the essential role of ocean science ahead of COP26.
Ocean science matters. See you soon on the Blue Planet.
Merci beaucoup. Vous avez vu Thomas Pesquet, et on va le retrouver maintenant parce que Thomas est un scientifique, mais c'est aussi un astronaute. Et il a, je crois, le record de nombre de jours dans l'espace pour un Européen. Et il va nous montrer une petite vidéo.
Hi, my name is Thomas Pesquet, and I just came back from the International Space Station. You might think that astronauts spend most of their free time gazing at the deep space up there, but what actually catches our eyes is the Earth below. Nothing compares to being able to glance at our entire planet through the space station windows. And the first thing that you notice is how just blue it is, overwhelmingly. The blue marble sure does deserve its nickname. I never really quite caught before my mission how interconnected the seas and oceans were until I could witness it with my bare eyes from space. There's actually only one unique ocean, as aptly underlined by this summit. We tend to see space as the ultimate frontier, the final frontier, the only remaining mystery. But the ocean is very much uncharted as well, despite yet another misconception. To think that more than 80% of the ocean is unmapped, unseen, unexplored is really mind-blowing to me. It is such a high number, it is hard to even comprehend how deep and vast this means the ocean actually is. We know so little about it, and that's why we need to start seeing the ocean differently and to take ocean exploration as seriously as space exploration. The ocean is mostly unknown and therefore often simply overlooked. As a very unfortunate consequence, there seems to be a general indifference to the threats the ocean is facing, and despite the fundamental role it plays in the Earth system. It is both our blue lung and our thermostat, absorbing around a quarter of all CO2 emissions overall and storing a huge amount of heat. The ocean has to be factored into the equation when we consider how to tackle climate change. We cannot fight the climate and biodiversity crisis without acknowledging and effectively taking into account the very interconnectivity of the ocean, the climate, and biodiversity. Of course, to fight climate change, we all as citizens have a role to play. But picking up a trash plastic bag on the beach on holiday is not going to save the ocean ultimately. Maritime transport, decarbonization, fight against illegal fishing and plastic pollution, biodiversity protection measures, and so on. We know that the effective response can only come from strong actions at a high level, and those can only be committed by decision makers. They can and they need to make the difference with bold, tangible, and actionable initiatives and commitments based on science-led solutions. Let's hope this workshop's conclusion resonates, and thank you to all the ocean scientists for their essential research.
Thank you very much. That was Thomas Pesquet on the blue planet seen from up in space. Now, it's a great pleasure to welcome Lorelei Picourt, the Secretary General of the Ocean and Climate Platform. And she's here in Brest, and we're going to have a short discussion on how the ocean, perhaps belatedly, is finally being given its due place in the climate negotiations that have been going on and continue to go on around the world. So, Lorelei, it's a great pleasure to welcome you here. Has the ocean always been given its due place in these kind of very lengthy international climate negotiations that we've seen over the years and decades?
Well, thank you very much, Victor. And first of all, let me thank François Houllier, Yves Rémer, and the One Ocean Science Dream Team for organizing this very important event. And trust me, as a relatively young woman, I'm very honored to be part of such a distinguished panel. So as we have heard, including from Thomas Pesquet, the ocean is absolutely essential to sustain life on Earth, and it plays a critical role in regulating the global climate system. But if we go back about 6-7 years ago, we already knew that, but it wasn't really acknowledged in the political agenda, and especially not in the international negotiations on climate change. So the first turning point, really, was COP21 in 2015 in Paris, where we had this singular opportunity to recognize and understand the role of the ocean in regulating the global climate system. So as a first step, we saw the mobilization of an international community through the Ocean and Climate Platform, but also other international partners and state coalitions, such as the Because the Ocean Initiative, that was led by Chile and Monaco. Of course, the support of the governments of France. And we managed to get the ocean in the preamble of the Paris Agreement. So that was the first step. But what happened since then, since 2015? Actually, when it comes to the ocean, we can be quite proud because there are maybe 4 areas where we saw significant progress. First of all, science, with the IPCC special report on the ocean and the cryosphere that was published in 2019, and that was truly a game changer, for the understanding of the ocean and its interaction with climate change. More recently, of course, we had the launch of the UN Decade of Ocean Science, and we're now, for the next 9-10 years, in this decade, which is really important. In terms of progress as well, we saw, greater national commitments, which means that countries over the world have included increasingly ocean-based climate solutions in their national strategies for adaptation and mitigation. We have seen unprecedented mobilization, including as part of the Ocean Action Days, as we mentioned, and we'll get back to that. And finally, in terms of policy making, in 2019, we had the COP25 in Madrid that was under the Chilean presidency, and that was the Blue COP. For the first time, the ocean made a grand entrance in the final decision of a COP, and that was the mandate under the scientific body of the Climate Convention to organize an ocean and climate dialogue with parties and experts to really discuss how we can strengthen ocean climate action under the UNFCCC. So we see growing momentum, and all of this, within 6-7 years is not short of a miracle under the United Nations.
And was that momentum maintained in Glasgow at COP26, or is it something, what happened there?
Absolutely, and first of all, when we talk about Glasgow, let me say that unlike what we saw in the very gloomy coverage of the COP, it was not a complete failure. No, we're not going to save the world in 2 weeks of negotiations. Delegations are mostly, debating on wording and brackets, so that's not the point. But Glasgow also allowed, to keep the 1.5 degree objective alive, and it managed to conclude the negotiations on the Paris Rulebook. So we did achieve some good things, although we expected greater ambition, of course. And when we look specifically at the ocean, we do have ground to call it a success. COP26 allowed for anchoring, really, the ocean in the climate negotiations. And I have 2 main points that I wanted to address here. First of all, of course, the main political outcome of COP26, the Glasgow Pact, the COP26 decision, recognizes the role of the ocean and marine ecosystems as carbon sinks. It's very clear in the decision that it's important to restore, protect those marine ecosystems. And additionally, the Glasgow Pact managed to, set up a mandate for an annual ocean climate dialogue under the scientific body, which means that from June 2022, we'll all have the pleasure to meet in Bonn during the intersessions to annually discuss, and I insist on the annually, because now we do have a platform to discuss gaps, knowledge gaps to be filled, also the progress and the priorities for the Ocean and Climate Nexus under the UNFCCC. And secondly, I want to briefly mention as well that all of these political outcomes were made possible because of the narrative that were built around the Ocean, Climate and Biodiversity Nexus, and including with the mobilization and coordination of member states ahead of COP26. There was a coalition of ocean champions, mostly led by Fiji, Chile, and the United States of America. And we saw the commitment, of course, of John Kerry just now. And this coordination ahead of time allowed for a strong narrative to get this ocean climate dialogue as a permanent decision in the Glasgow Pact. So that was very important. And to come back to the Ocean Action Day, I think we're noticing a very strong mobilization of non-state actors across the sectors for the ocean, and for the first time, 120 organizations, from NGOs to scientists to the private sector as well, agreed on a narrative and signed the Ocean for Climate Declaration, which was presented at the Ocean Action Day to mainly scale up ocean action. And not to brag, but the Ocean Action Day was actually the most viewed event as one of the Action Days at COP, and that was mostly due also to the participation of the One Ocean Science and Thomas Pesquet in this important event. So we can see a growing momentum, and of course the road is still very long.
Yes, I mean, tell us about that. What are the, so governments are beginning to sit up and take notice, people are beginning to take notice. What are the really urgent priorities now for the years ahead? What do you think we should all be focusing on? What will we be focusing on?
First of all, of course, one of the priorities, or the main priority if you want to safeguard the ocean, is to drastically reduce greenhouse gas emissions, for sure. But mitigation and adaptation, including ocean-based solutions, are very much at the top of the list as well. So in the next revision of the national strategies for the member states, we encourage more integration of those ocean-based climate solutions, from the protection of blue carbon ecosystem to the decarbonation of the transport industry, as well as boosting marine renewable energy. So we hope to see more of these solutions included in the national strategies. And additionally, and more to the point of why ocean science matters, as mentioned, we'll have this annual ocean climate dialogue, and here precisely we're shifting from a very policy-focused strategy to a more identifying the priorities, what are the themes that we need to highlight to the experts, to the member states, to safeguard the ocean. And here precisely the work of scientists will be absolutely detrimental, because we need to gather existing knowledge and feed in this discussion on how science can really be the basis for equitable and sustainable decision making. But we also need, scientific institutions to shed some lights on what are the upcoming challenges and share their creativity on identifying those main challenges. How can we address them? And in that regard, and I know I'm being a bit long, so I'll conclude here. But just to reaffirm that you can count on the Ocean and Climate Platform, all of its members, Ifremer, all the scientists out there to really ensure this science policy interface and be the voice of the ocean in the climate negotiations.
Lorelei Picourt, thank you so much for that extremely practical and positive. I think it's quite important that we remain hopeful, and you've laid out the ways in which we can have hope, and there are practical things that can be done to help solve a lot of the issues that we're facing. So thank you very much, Lorelei Picourt. Now we're going to go to southwest France, and two leading scientists at the Priority Research Program on Ocean and Climate that was set up or funded by the French government. And the first person we are going to have intervening is Catherine Jandel, who's the co-pilot of the PPR. Catherine, if you're online, can you tell us what you're focusing on at the PPR?
Thank you. Thank you for inviting me. Do you hear me clearly?
Yes, indeed. We can. Thank you.
The ocean science operation illustrates how much the ocean matters to humanity, as it was already underlined, and that ocean science also matters. And with this aim, the French government is currently investing 40 million euros in a priority research program called PPR, and which is entitled An Ocean of Solutions. The main objectives of this research program of high priority are to better understand the functioning of the ocean in order to better protect it by anticipating its evolution under the stress induced by human activities. Ultimately, the aim is to propose adaptations to these changes, such as that induced by the inexorable rise in sea level on the coast. Solutions are also expected to reduce the exposure of marine organisms to various stresses and pollutions, and for a more recent exploitation of the seas, whether it be fishing or mining resources. A major challenge will be to preserve and even restore marine biodiversity, since it is already highly impacted by our human activities. Thus, this program is totally in line with One Ocean Science. The calls that were launched for this program proposed to the scientific community to be structured in consortium of researchers around key scientific challenges and on targeted geographical territories. As overseas territories, the deep ocean, the ocean below 200 meters is already completely unknown or barely known, very barely known. The polar oceans, vulnerable marine and coastal areas of metropolitan of France. So that are the regions that are targeted in priority. But also cross-cutting and innovative methodological approaches like observations, data acquired from many diverse tools like ship cruises, buoys equipped with sophisticated sensors, drones, AUV, satellites, and modeling, as well as strong science society links were strongly encouraged in the call. A high priority of the PPR is indeed to involve the civil society in the protection and enhancement of the ocean. So far, 20 proposals were submitted by the scientific community for evaluation by the International Committee last November, and the evaluation procedure is ongoing. But this is a very encouraging sign. This PPR is part and completely timely with an international movement to prioritize research efforts on the ocean. With the challenge covered by the PPR, we will contribute to the UN Decade and to the mission Starfish 2030, which is to restore our ocean and waters by 2030. Indeed, the PPR issues are fully in phase, in line with 4 overarching objectives of Starfish: filling the knowledge and emotional gap of the society, regenerating marine and freshwater ecosystem, marine, by the way, zero pollution, and decarbonizing our ocean. By giving a global visibility to the research conducted on the ocean within the framework of the PPR, One Ocean Science perfectly illustrates the importance of these issues and that the national mobilization around the big program PPR is central in this landscape.
Catherine Jondal for giving us that quick overview of some of the very varied and important issues that you're dealing with, from marine biodiversity to deep oceans, polar oceans, and all the other areas that you're going to be helping to study. Now we're going to turn to another PPR. In fact, she is the chair of the Scientific Council of the PPR, Yun Xin, who's also from the IRD, the Research and Development Institute. And she's going to tell us a little bit about the challenges that she and the PPR face. What are your priorities going to be in the months and years ahead? Yun Xin.
Good morning. As my colleague Catherine Jondal explained, we are facing unprecedented scientific challenges for the ocean because of major upheavals linked to the acceleration of human activities. So after François Houllier and Lorelei Picaud, allow me to reiterate here and today at this One Ocean Summit and at the eve of the COP15 on biodiversity, that the climate, the ocean, and human societies are closely linked and interdependent. And this is how the French research program PPR was conceived. Climate change impacts the ocean, its biodiversity and its ecosystem services, and conversely, the ocean and its biodiversity regulate the climate by absorbing excess heat and sequestering atmospheric CO2. And what will be decisive for the future of our oceans is firstly, our ability as scientists to understand the functioning of the ocean system as a whole, because everything is interrelated. And secondly, the ability and willingness of our societies to manage all our activities on the ocean in a sustainable, integrated, and cross-sectoral way. Until now, the exploitation of marine resources has led to the greatest loss of marine biodiversity. But it's also, of course, climate change that has increasing negative impacts and pollution and coastal uses. So let's take fishing and climate change as drivers of change. And I'll quickly give you 2 examples of interactions. The first example concerns the impact of climate change on biodiversity. Scientific models have recently shown that if we don't significantly reduce our greenhouse gas emissions, we can expect a decrease in fish biomass of about 20% by the end of the century. This is not good news, neither for biodiversity nor for food security, especially since these future projections do not take into account the negative impacts of overfishing, nor pollution, nor habitat destruction. And it's all the more worrying that this decline is exacerbated in the entire intertropical zone, where the poorest human populations on the planet live, and which are very dependent on fisheries resources. But conversely, and this is my second example, the exploitation of the sea can have an impact on climate change. Let's take the deep ocean, that part of the ocean beyond 200 meters depth, which represents 95% of the total volume of the ocean. It's actually the largest biome on the planet, also the most unknown, and which constitutes the largest stock of anthropogenic carbon after the atmosphere. Well, this deep ocean is the object of covetousness, as you might know, with its mining and energy resources, but also its wealth of mesopelagic fish, whose biomass would be 10 times more important than the one that is currently fished on the surface. Now, these fish participate in what is called the biological pump that allows the sequestration of carbon in deep waters and in the seafloor. So, if the exploitation of these mesopelagic fish were to be developed on an industrial scale, we don't know yet precisely what serious consequences this could have on the release of carbon into the atmosphere and therefore on the climate system. This work on biodiversity and climate interactions is underway in many scientific teams around the world. Last year, the IPCC and IPBES have worked hand in hand to produce a joint report to assemble the most recent scientific evidence showing the multiple interconnections between biodiversity and climate change. But while observations on the oceans are improving and while numerical models are being refined to quantify the impacts and forecast, let's not repeat the same mistakes as in the past by exploiting a resource in a blind way, that is, without taking into account its role in the functioning of ecosystems and without taking into account the many ecosystem services provided to human societies, including climate change mitigation. And I finish here with this last message that I want to convey, is that climate change mitigation measures exist, as well as measures for better management and conservation of ecosystems. So with the help of our models and the field data on which they are based, we can test the levers and solutions that need to be activated today to put us on a virtuous trajectory for our future. Thank you.
Thank you very much to Yun Xin and Catherine Jondel of the Priority Research Program on Ocean and Climate for that overview of some of the very serious scientific challenges that they're going to be dealing with in the years ahead. Now we're going to go on a tour of the world. We are going from the Asia Pacific to the Americas to Africa, back to Europe. And we're going to hear from 10 scientists about the work that they're doing in a range of essential and sometimes quite entirely new fields of study related to the ocean and to its impact on the climate in many cases, and the parts of the ocean and things about the ocean that we're only just beginning to discover. And there's a short introductory video to this session that we'll see now.
The ocean. From the child splashing in the waves to the explorer diving into the deepest abyss, the ocean connects us, unites us, makes life possible for each inhabitant of this planet. It covers more than 70% of our blue planet, just like our body is made up of 70% of water. But make no mistake, it's not just a postcard or a grocery store. It lives, breathes, evolves, and suffers. Everything that lives, not just humans, depends on it. Our lives are intertwined. One way or another, we are the ocean. Listen, and let us be clear. We are the ocean. And yet, we tend to dismiss it. we turn our backs on the ocean, but our future depends on its health. We scientists are working hard to build a safer, healthier, resilient tomorrow. We don't just produce data, we build the world's most reliable source of knowledge to preserve the ocean. To fight climate change, we must save the ocean. Because without science, there is no future. Simple as that. And this is why we are here today. To create that critical wisdom and nourish our spirits to preserve the Earth's life support. This is a wave. A giant one. One Ocean Science.
Our first stop is going to be in Fiji with Dr. Moritz Vandres, who is at the Physical Oceanography, Geoscience, Energy and Maritime Division of the Pacific Community. And he's going to tell us a little bit about, I think, some of the things that are not necessarily man-made, but about how we deal with all kinds of disasters, including natural ones. Moritz Vandres.
Yeah, thank you. As you know, the Pacific region is one of the most natural disaster-prone regions on the planet. Because many Pacific Island countries are low-lying, they are highly exposed to the adverse effects of climate change and natural hazards coming from the ocean. Natural hazards have affected millions of people in the Pacific region and also, unfortunately, caused thousands of deaths in recent decades. In terms of monetary cost, the disasters cause about billions of dollars of damage every year. For example, Tropical Cyclone Winston in 2016 caused damages of around $2 billion, which is about 20% of Fiji's GDP. The cost of natural disasters is likely to increase with climate change. For example, it's virtually certain that the global mean sea level will continue to rise over the 21st century, even in the most optimistic emission scenario. At the same time, we've observed an increase in the occurrence of major tropical cyclones, or hurricanes, over the last 4 decades, and this trend is also projected to continue with global warming. There's also evidence that extratropical storms, so high-latitude storms, will intensify. So with that, it's obviously critical that Pacific Island countries have the systems and the right tools to predict these flood events. So flood events, coastal flood events, are compound events where astronomical tides, mean sea level anomalies, and waves all interact to create an extreme sea level near the coastline and then flood the coastline. And unfortunately, global weather forecasts are not very good at predicting these compound events. And there's a few reasons for that. Firstly, global models are too coarse to actually resolve all the effects of those small islands that we're dealing with. And secondly, we've already heard it a few times now, we're actually lacking a lot of accurate baseline data. So in most places, or in a lot of islands in the Pacific, we actually have no idea where the island sits in terms of the mean sea level. So obviously that's a large problem. And then also the physical processes that need to be resolved to accurately predict coastal flooding in reef-fronted islands is quite different to the processes that we would resolve in a continental Europe or continental United States, for example. So the Pacific community, we've been developing forecast systems that are specifically tailored to the needs of Pacific Island countries. Firstly, we go out and we collect high-resolution baseline data using boats, drones, we use satellite data, and even planes. We then develop really high-resolution models that can capture all these small, fine-scale effects around the small islands. We also use machine learning and artificial intelligence to predict coastal flooding. The models that we develop are then implemented at the National Meteorological Services, where forecasters can use them to make predictions. So they can say, in the next 7 days, this part of an island is going to be flooded or not. There are currently 3 systems that we've developed. One is in Tuvalu for the entire country, and one for parts of Fiji and one for parts of Kiribati. Our colleagues at the University of Hawaii have also developed similar systems for American-affiliated countries. But that shows you that many countries are still without any tailored flood forecast systems. So to prepare the Pacific for the effects of the climate change, we really need to heavily invest in the collection of accurate baseline data. We need to establish long-term ocean monitoring systems, and we also need to invest into the development of tailored forecast systems for the Pacific Island countries.
Thank you very much, Moritz van Dres. And of course, we are reminded of the unpredictable power of nature, even without human intervention, from the undersea volcano that caused such damage in Tonga recently. So thank you to you on the situation in Fiji and the South Pacific and natural disaster management or disaster management from climate change and other events. We're now going to turn to Japan and Dr. Naomi Harada, who's Director General of the Research Institute for Global Change at the Agency for Marine Earth Science and Technology. And Dr. Harada, I think, is going to talk to us a little bit about a problem that we all see. If anyone has sailed boats or been around the world on ships or even just going swimming in the sea, we see this everywhere we go, from Europe to Asia and beyond, and that is the problem of marine plastic pollution. Dr. Harada.
Okay, thank you very much. So good morning, good afternoon, good evening, everyone. So thank you very much for giving me this opportunity. So today I'd like to focus on marine plastic debris because Japan is a large country consuming plastic products. Do you see the first slide of my presentation? Okay, good. So do you know how much plastic trash flows into the ocean and rivers each year? As much as 90 to 23 million tons flow in annually. This is the amount of plastic garbage that is full of large garbage trucks through into the sea or river once every 2 seconds for 365 days. According to United Nations Environment Program data, the amount of plastic that should be floating on the surface of the ocean, of the open ocean, is 45 million tons. But the amount of plastic on the ocean surface that was actually observed is only 0.4 million tons. And the plastic on the ocean surface is just the tip of the iceberg. Where did the remaining 99% of plastic go? Around Japan, there is a strong current called the Kuroshio Current, which is the largest westerly boundary current. And in the upstream area of the Kuroshio Current, there are countries with large amounts of unmanaged plastic waste. It was thought that plastic trash from the upstream area of the Kuroshio might have reached the Kuroshio Current and sunk somewhere around Japan. Therefore, we investigated marine plastic in the deep sea floor in the Kuroshio Basin by submersible. Next slide, please. So this figure shows a lot of plastic debris found on the deep sea floors around the world by area. When we plot the survey results of the Kuroshio Current Basin, it was that the number of plastic waste per 1 square kilometer is 2 orders of magnitude higher than any area in the deep sea of the world. In other words, the deep sea bottom around Japan was a hotspot where plastic is accumulated. The next slide, please. So there is concern about plastic pollution of deep sea organisms. Contaminants such as flame retardants and UV absorbers are used as plastic additives. Due to the long lifespan of deep sea organisms, pollutants accumulate over a long period of time and some of the deep sea organisms are fishery resources, which may affect our diet. I would like to give taking a home message. Investigation in marine science has uncovered the reality of marine plastics. A lot of marine plastic waste is accumulated in the deep sea, and it is impossible to collect it. Everything comes out of our lives as unmanaged garbage. On the other hand, it is also a fact that the development of plastic supports dietary habits and medical care safely and hygienically. It is important for various stakeholders to think about how to use the minimum amount of plastic products under good management. Thank you very much for your attention.
Thank you very much, Dr. Harada. Thank you very much for that intervention. And I have to say, I for one, learned a lot of things that I didn't know. Obviously, the surface plastic that we see on beaches and on the surface of the sea is really only the tip of the iceberg in this case, because there is so much down there on the bottom that we don't think about enough. And thank you very much also for your message of how we should try to change our behavior. We're still in the Asia Pacific now, and we're going to Singapore, and Dr. Hari Vishnu, who is a Senior Research Fellow of the Tropical Marine Science Institute at the National University of Singapore, who's going to talk about a very interesting and slightly unusual topic, I think, for most of us, and that is how you listen to the ice melting. Hari Vishnu.
Good day, everyone. I'm Hari Vishnu from National University of Singapore, and I'd like to talk about the ongoing research by me and my collaborators on the sound of melting glaciers in the Arctic. Studying the melting of glaciers is very important to gauge how climate change translates into sea level rise. Specifically, we are looking at Svalbard, where glaciers meet the ocean. Here, there is warm water that comes into the fjord, melts the ice, and then retreats out, thus forming this complex oceanic circulation. So it's very clear that you can't view the ice system separately from the global ocean, right? They are very much connected to each other, and we must look at the ice and the ocean together. So obviously, ocean science plays a very important part in studying these glacier regions. Now, the environment at the glacier is dangerous because these areas have calving activity, and large ice chunks are falling down constantly. You can see ice chunks floating around in the photo, for example. So we can't get close to the glacier to study them. We need to study the glacier from a safe distance and over a long time. How do we do this? We propose that one way to do this is using the underwater sound. Sound is a good way to sense the oceans because it travels long distances underwater compared to electromagnetic waves. So in the ocean, sound is a window into what's happening, essentially. Now, at the glacier, a large part of the ice is lost through underwater melting by warm water. And this melting produces a loud crackling sound, which reminds me of frying potato fries in oil. So in case you wondered, that's why I have a photo of potato fries up there. Have you listened to that sound? I'm sure you have. This glacier sound is produced by explosion of bubbles, which were trapped in the ice. And just listening to the sound of the bubbles gives us an opportunity to monitor this melting. So how does this melting ice sound like? Well, here's an example of the sound. Pay attention to the loud pop sounds of the bubbles. Can we have the audio, please? Right. All right. So the sounds you heard are very loud, and they can be heard far away from the glacier. We all like to think of the Arctic as a serene and silent place, but ironically, it's very noisy underwater. To study this, we have been recording the underwater soundscape in Svalbard with a setup like you see here. We went on a boat to the glacier, used a vertical line with many underwater microphones attached, and recorded the sound over a couple of weeks. And when we look at what the sound is telling us, we see energy from multiple events happening there. We see even energy from the melting of the glacier. That's that small orange horizontal line you see there. We can see other pieces of ice floating by us, and there are pieces of ice falling into the water, and so on. So Without going into details, the takeaway message from our experiments and our results is that the underwater sound tells us a whole story of what's happening at the glacier. There's melting and calving, and there are ice pieces that float by, and all these events are captured in the sound story. So our research dream is to use this sound to study how fast the glaciers are melting. Our idea is more melting means more bubbles, which means more sound, right? So from this sound, we should be able to tell how fast the glacier is melting. My future research will focus on this, and one day we hope to use this sound to calculate how fast glaciers are melting in Svalbard, in Greenland, or Antarctica, just by dropping a bunch of underwater microphones in there. That is my research in a nutshell. I'd like to mention this was a collaborative work with Scripps Oceanography and Polish Academy of Sciences as well. Thank you.
Thank you very much, Hari Vishnu from Singapore. That was absolutely fascinating. I'm now aware of what Arctic popcorn sounds like. It really does sound like something cooking down there. So thank you very much for that. We're now going to go, we're going to leave Asia Pacific and head across to the Americas, where we have Paulo Nobre, who's a climatologist and researcher at the Brazilian National Council for Scientific and Technological Development. And he's going to talk to us a little bit about risk and disaster management, and particularly oil spills. Paulo Nobre. We haven't got your sound. I think you're on mute, Paulo Nobre. Could you unmute your microphone, please?
Thank you very much. Good day, and thank you very much for the invitation. I work at the National Institute for Space Research, and now we can start. So oil spills are something frequent in the world oceans, and we are used to see it in the beaches, the small pieces of oil that we step on. But in 2019, the next slide, please, we have had a major event of oil spill that reached Brazil shores, and we collected more than 5,000 metric tons of residuals, oil residuals. This is stretched across 2,900 plus kilometers of shorelines. And then we have 50 plus sanctuaries affected with oil pollution, and more than 30 endangered species affected. So it represented a very strong socioeconomic impact and left behind a decades-long environmental poisoning situation in Brazil. So in the next slide, we will see what the response has been in the country to deal with common events of oil spills and pollution. So a coalition of researchers have been developed nationwide with more than 20 research institutes and universities, the Institute for Natural Resources, IBAMA, and the Brazilian Navy. Together, we are working jointly to build a multi-user systems to detect, predict, and monitor oil spills with the focus on deterrence, so that ships know that they are being observed. The system is based on synthetic aperture radar imagery, airborne active sensors, in situ buoy data, and a state-of-the-art high-resolution coupled ocean atmosphere modeling that we are developing in the country. We are also planning a constellation of Earth observation satellites, probably CubeSats or small sats, to observe 24/7 the ocean. And all those data and model results are inputs to an AI algorithms to detect ship displacement and oil spills. When an oil spill is detected, then oil dispersion models run to gauge the probability that oil residuals will reach the shoreline. Once that is determined, IBAMA and the Navy are activated accordingly so that prevention actions can be taken, depollution, etc. So what were the lessons learned from this huge oil spill in 2019? One is that oil spills are frequent, if not daily, worldwide. The way to go, the union of national labs to detect and predict oil pollution, taking in mind the importance of international cooperation, which is key for developing a worldwide capability to protect our environment against such nasty kind of pollutions, which are long-lasting oil pollution. So we rely on international cooperation, which is key. Mercator products, NOAA models, and our work here in Brazil with the INPE, IBAMA, and the Brazilian Navy. And not to mention the Piratabuia Ray, that is a France-US-Brazil long collaboration. To end, I would like to say that when the system is ready, the ones that we are developing, oil spill in Brazilian waters will be detectable and its reach predicted. Thank you.
To you, Paulo Nobre, for that, on how we can monitor and assess oil spills in Brazil and indeed around the world. Now we're going to the US, where we have a short video from Margaret Leinen, who's director of the Scripps Institution of Oceanography and vice chancellor of the University of California in San Diego, who's going to talk about the Ocean Biomolecular Observing Network. So if we can have that video, please, from the US.
Hello, I'm Margaret Leinen. I'm the director of Scripps Institution of Oceanography at the University of California, San Diego. And today I want to talk to you about some exciting new developments that are going to let us look at biodiversity in a new way. Every organism in the ocean, from whales to the smallest microbes, releases DNA and other biomolecules to ocean water. It may be metabolic waste, skin or cells that are sloughed off, or the remains from when the organism dies. But recent developments in the technology for analysis of these molecules now allows us to detect organisms by simply analyzing the water that they have been in. Early research using this capability has shown us that we haven't even come close to identifying the diversity of life in the ocean. Using these techniques, we can now look at biodiversity in a whole new way. We can actually, for the first time, detect everything that has been in or around a water sample. And I mean everything. This is not just for big things like fish and whales. Microbes in the ocean, like bacteria and viruses, are as important to ocean life as viruses like COVID and microbes like those causing malaria and cholera are to us. Microscopic organisms are also the symbionts that supply food to corals. Free-floating microbes are some of the most abundant species in the ocean, and 20 years ago, we didn't even know that many of them existed. We can now observe the biodiversity of the ocean so much more easily. Of course, we will still go out to sea to look at things, but now we can see the things that we have been missing. Missed because we could look in so few locations. Missed because the cost of going to sea is so great. Missed because the organisms weren't always there. And hidden because the organisms were too small to see with our eyes and our cameras. We are also beginning to understand how to use biomolecular analyses to understand how big the population of specific species are. In a few years, we may not have to catch, kill, and count things to understand how abundant they are, or photograph and count them to understand how abundant they are. And we'll have a much better idea about whether specific organisms are present everywhere or just in a few places. This new capability is revolutionizing our understanding of ocean biology. Who is there, how abundant they are, how they're responding to the massive changes that are taking place in the temperature and chemistry of the ocean as a result of climate change. This is a biomolecular revolution for ocean science, and scientists around the world have begun to work on it. It's also one of the endorsed programs of the UN Decade of Ocean Science for Sustainable Development. It's called the Ocean Biomolecular Observing Network, or OBON. Stay tuned. We promise this is a revolution that we will televise. Thank you.
Thank you for that from Margaret Leinen on a revolutionary method that's being developed and used increasingly to work out what life is in our oceans. Now we're going to Africa and the Western Indian Ocean Marine Science Association, and its president, Dr. Jacqueline Uku, who is talking to us from Mombasa in Kenya, I think, and going to tell us a little bit about how ocean science and research and coral reefs can tell us a little bit about how we can improve our climate risk management. Dr. Uku.
Thank you very much, and hello everyone. I lead an association known as WIOMSA, which is domiciled in Zanzibar, Tanzania, and it's an association of marine scientists. We support and coordinate regional research in marine and coastal management in our region, which is also known as the Western Indian Ocean region. WIOMSA supports professional networks, and these include WIMS, that supports women, WIOSIN, which supports youth, and WIOPAM, which supports marine protected area practitioners. We support members and countries to implement the Paris Agreement under our Marine Science for Management Research grant known as MASMA. Further to this, in terms of climate, we are developing a climate portal to enhance regional information exchange. And we have a very interesting program known as the Cities and Coast Program that has been undertaking vulnerability assessments of our coastal cities to climate change. In our region, the ocean is our food basket, literally. It nourishes us physically and spiritually. And so ocean health is essential for African nations, especially when we are considering the development of blue economies. Fishery sectors stand out, and ocean-related changes can be seen through that sector very often. These changes are very visible on land and they're easily documented, but the ocean remains a mystery, and changes due to climate are not very easily seen. They still remain hidden. So our goal in WIOMSA is to invest in ocean science to track these hidden changes and their impacts. It is important to know what is changing, the rates of change, in order to support communities to build resilience and coping mechanisms. One area that we are seeing greater visibility to climate change is the constant bleaching of coral reef ecosystems in our region. We have, and we are home to about 6% of the total global area of coral reefs. And so our region is a hotspot for coral reef biodiversity. Over the years since 1998, we've seen a decline in coral cover following global bleaching events. Our scientists have participated in data collection because the science is important in understanding the impacts of the bleaching events, the recovery of reefs. We need the science to understand coral resilience to these climate change issues, diseases, the fishery, the genetics, and also the dispersal patterns of corals, as these have impacts on community livelihoods. The thing that stands out on a platform like this is the advancement of how researchers work with decision makers to co-create knowledge. And as this is a very important aspect of science in our region, we then, to enhance this, we have a science to policy platform that is hosted between WIOMSA and the Nairobi Convention. And we are relooking at the design of ocean science because up to now, we've designed our science for knowledge generation and often not for problem solving and for policy. And so it is important in our region, and we are seeing a lot more legislation taking up the science to advocate the use of research. We are seeing more partnership with policymakers, especially in the Blue Economy Dialogue, and also the recognition that planning such as marine spatial planning for the blue economy cannot do without the science. I'd like to just add as I close that we need to be very inclusive and ensure that there is gender equity and to incorporate the voices of women, both at scientists and at the community level, because in our region, we often find that they're left behind. And this is a really important consideration for the women of our region to be included in a lot of this dialogue at the science and policy level. Thank you.
Thank you very much, Dr. Uku, both for that final message and for the ways in which we need to track the changes that are happening in our oceans and therefore in our climate. Thank you so much for that from Mombasa in East Africa. Now we're heading up to the Mediterranean and Tunisia, where we have Dr. Ali Hazala, who's head of the Laboratory of Marine Environment at the Institut National des Sciences et Technologies de la Mer, who's going to talk to us a little bit about, I think, about some unusual events that you've seen or noticed in the seas off Tunisia. Dr. Hazala.
Yes, that's right. Thank you very much for the invitation. So I start my talk by citing some events that have occurred in recent years along the Tunisia coast and which really have marked us. In 2019, the sea waters over large areas of the coast of Sfax in the east of Tunisia turned red, so the entire water was colored in red. Last year, in 2021, the extremely venomous jellyfish called Portuguese man of war, or La Galère Portugaise in French, was spotted in Tunisia coasts. It induced a panic in the country. But even before those dates, in 1993, the blue crab appeared in the country, and even it represents 70% of catches in 2014. In 2010, the rabbit fish, in French it's called le poisson lapin, with venomous spikes, has been reported in Tunisia. Its photo was posted on the fishing harbors of the country and on media. Also, we noticed uncommon and sporadic nesting of the endangered species sea turtle that was observed during last years in several beaches. It is a joint effort in oceanography, in close connection with the atmospheric sciences, and advances in terms of satellite observations and numerical modeling that makes us able to provide answers to the origins of such phenomena. The Tunisia marine environment is undoubtedly closely linked to the global ocean. The venomous jellyfish reported in Tunisia is evidenced to be transported by the so-called Atlantic vein, probably from the Atlantic Ocean along the African coasts. Indeed, it was reported on the Algeria coast a few days earlier before reaching Tunisia. Invasive species are related to the warming of the water, 1 degree in the Gulf of Gabes already. Most of them enter the Mediterranean from the Red Sea through the Suez Channel, although the commercial navigation around the world may also contribute. Several thousand kilometers away, the eastern Gulf of Mexico is also a hotspot for red-colored water events, called the Florida red tide. So climate variability and climate change are found possible contributing effects to the occurrence of this phenomena. Hence, we share the same ocean, the same worries, and the similar scientific questions. INSTM, the Marine Scientific Research Center in Tunisia, nearly 100 years old, joins the global effort to understand and plan the future of the ocean. Along the Tunisia coasts, an increase of the sea temperature by 1 to 3 degrees is predicted in 2050, highest in the Gulf of Gabes in the eastern coasts. The number of new species, presently 40, will double, and the sea level will rise another 30 centimeters. The uncommon sea turtle nesting, which is attributed to the escape from the increased warming waters in the eastern Mediterranean to the relatively cooler zones in the western basin, will continue and even increase. Attenuation and adaptation programs were discussed and defined, but some ongoing and planned actions could, in opposite, exacerbate climate change impacts. Seawater desalination units are surely helpful in our fight against the increasing water scarcity, especially in North Africa, but are energy consumer and may dramatically impact the sea flow through the extremely high salty water poured to it. Indeed, power plants and seawater desalination units are in most cases set next to the sea. So to conclude, these are examples that show how complex the situation has become. Mitigation and adaptation measures should be well planned in close collaboration between decision makers and scientists to not add pressure to our ocean. Thank you very much.
Thank you very much, Dr. Hazala, for that intervention on invasive species, Red Sea phenomena, and all the other unusual effects of ocean warming and of course our movements around the world's ocean. Thank you very much. We're now going to go to Romania and Adrian Stanica of the Romanian National Institute of Marine Geology and Geoecology, where he's the Director General. He's going to talk a bit about sustainable management of river sea systems. Dr. Stanica.
Thank you very much. I'm going to introduce an initiative to develop a distributed research infrastructure dedicated to study of river sea systems. And why is that? Well, because rivers and the seas under their influence, the cradles of humanity, have been the environment suffering most from the explosive and uncontrolled use of resources that has affected the planet over recent centuries. Humans have played a major role in the abrupt change of climate and hydrologic cycles, and classical science methods have not managed to find solutions to let humanity live in harmony with nature. A new way of approaching science is needed, with researchers from Earth, life and social sciences working together, treating rivers and the seas under their influence as a continuum. Danubius RI, the International Center for Advanced Studies on River Sea Systems, is the initiative that will provide the scientific services needed for this interdisciplinary and innovative paradigm. It is a pan-European research infrastructure with components distributed across 10 European countries. Instead of starting afresh, we have been building Danubius RI by harnessing the existing scientific expertise in Europe. And our purpose is to bring together researchers not only from different disciplines, but those working in different ecosystems, such as those involved in freshwater, transition zones between rivers and seas like estuaries and deltas, as well as those specialized in coastal and marine studies. Danubius RI will offer a range of scientific services to those wishing to develop and implement sound sustainable management of river sea systems. From remote and in situ observation to specialized analysis, from development of conceptual understanding through numerical modeling to creation of management scenarios, Danubius RI will have an open access policy for data and other products to scientists worldwide to help find solutions to global problems. Besides the laboratories and scientific expertise, there is another feature of Danubius RI that stands out: the super sites or living laboratories. From the Lochs of Scotland to the Guadalquivir estuary, from the Thames and Ebro to the Rhine and Danube Delta, these are natural sites of high scientific interest, where our services will be made available for the community of users, be them visiting researchers or academia. Led by Romania, Danubius RI has applied for the legal status of European Research Infrastructure Consortium, for Eric. It will start becoming operational over the next couple of years, supporting the process understanding of complex connections between climate and river-sea systems.
Thank you very much. Dr. Stanica, I have a soft spot for rivers because I studied the history and geography of the mighty Ganges in India, so I'm very glad to hear your work on river and sea systems and connections. We're now going to turn to Italy's National Research Council, and Dr. Chunshui Yang, who's going to talk to us a little bit about the role of ocean circulation in climate change. And over here on the eastern side of the Atlantic, of course, we're all quite concerned about what's happening to the Gulf Stream. So, Chunshui Yang.
Thank you very much. It's my pleasure to share our research activities to answer the question why ocean matters and also our solutions. So we have been working on understanding the role of ocean circulations in regulating the global climate. As we all know that the ocean water is not static, it's moving. They are moving and moving all the time. As it shows in this image, that the continuously moving water, we call ocean circulation, they distribute heat, salt, nutrient, and also plastic, just like mentioned Naomi in the Kyushu area. So particularly also in the ocean circulation in the Atlantic, just mentioned by Victor, that it transfers the heat from the tropical regions to the polar regions, really affect our climate. Because of this, any changes of ocean circulation will affect our climate. So the fundamental question we want to answer is how the ocean circulation changes, and also the interactions between the ocean circulation and the small features just mentioned before, the waves, the eddies, and also how it impacts our climate, also the biodiversity we just mentioned several times here. But what kind of data do we use to tackle this question? The most important data and the most used data, actually the observations we collect from the sea. Next image is our platform in Venice and also Cinque Terre. You will see later exactly here. The observations we observe along the coast in Italy, but not only along the coast, but also in the open ocean. Scientists already implemented instruments to observe the ocean currents. So it allows us to understand the ocean currents more deeply and more widely. But not only the observations in the sea, we already mentioned several times also the satellite data set. For example, the future emission SWOT will really provide us very high resolution satellite images about the ocean small features. So the second question we would like to understand is how can we use this huge amount of data set to extract essential information about the ocean circulation and also the climate change. But however, the observations cannot solve everything because we cannot have observations every single point of the ocean and also stay there for so many years, especially if we would like to know our past in the last 20 years, 50 years, even 100 years, in order to predict in the future. So one alternative is ocean models. We also mentioned several times here. To solve this problem, we simulate the ocean circulation, the ocean itself, by integrating the mathematical equations in supercomputers. So next image is the sketch of the numerical model concept exactly here. So we divide the Earth into small cells and try to solve it. But if you see in this image, the ocean is intact with the atmosphere, with the sea ice, with actually the glaciers, just mentioned by Harry before. So it's a really complicated system. So in order to simulate this ocean circulation or ocean or climate itself, we have to do assumptions because it's too complicated. Also means that the model is not perfect because if we do assumptions, it's not perfect. So the third challenge we're facing right now is how to improve the model and how to combine observations with the model to increase the capability of these models to represent our climate or our ocean in the past and to predict in the future. Not only the global scale, in our institute, we also work on the Mediterranean, also mentioned by Ali just before, the Mediterranean domain. Yeah, that's what I have. Thank you very much.
Thank you so much, Chen-Shui Yang, on the complex business of modeling ocean circulation and, of course, its importance for our climate. The last stop on our world tour is in New Zealand with Dr. Kevin Mackay, who's a geologist at the National Institute of Water and Atmospheric Research. He's going to talk to us a little bit about something we don't think enough about, but probably should think more about, and that is what's down there on the seabed.
Yes, thank you very much for the introduction. Tēnā koutou katoa, in the language of our Indigenous people of New Zealand, the Māori, greetings to you all. I'd like to give a presentation on the sea floor and actually with the understanding that this is actually a fundamental part of the Earth's and the ocean's systems, but it is probably one of the least understood. And I'm going to start with a video. Can we play the video, please?
The name Earth to describe the planet is a bit of a misnomer. It should be called ocean because 70% of the Earth's surface is actually oceans. In reality, if you look at Google Earth and you see these lovely pictures of the sea floor, in actuality, it's only 20% of that comes from real data. The way we map the oceans is by something called echolocation, where we send out a pulse of sound, a ping if you will, and then we listen for the echo, which is a pong, and if we time the difference between the ping and the pong, that will let us know how deep the ocean is. The CEBA 2030 project aims to have the entire world's ocean seafloor mapped by the year 2030. Here at NIWA, we host a South and West Pacific Regional Data Centre, and this data centre has responsibility for the entire South Pacific Ocean. The oceans drive the world's climate, and if we don't understand the oceans, then how can we understand and manage and predict what the world's climate will do and how that will affect humanity in the future?
Okay. Right, so thank you for that video. So that raises the next question, and this is the point of this meeting. Why does Map the Seafloor matter? Why does ocean science and mapping the seafloor matter? Well, there are three main reasons why this matters. The first is for safety of navigation. Now, while most shipping lanes and ports have been well mapped and various nations have dedicated authorities who are responsible for mapping these, there are many coastal states, especially small island developing states, that do not have the capability to even navigate or even locate their islands and ports to any degree and for safe navigation. So one of the things that we're doing at CEBA 2030 is working with these smaller nations to map their sites for safe navigation. The second reason why ocean science or seabed mapping matters for ocean science is for marine conservation and resource management. The sea floor is where geology meets biology, and if you want to understand the geology or the biology, you have to map the sea floor. And the third reason is for risk mitigation, and risk mitigation needs to have good simulation models running to really understand different processes such as sediment transportation, surface and underwater currents, storm surges, and tsunami wave propagation. So I'm going to switch now to a real example of an event that happened last year, a tsunami, where new mappings from the CEBA 2030 project, new undersea mappings, have directly resulted in an improvement in tsunami forecast. So if you see from this animation, an earthquake, an 8.1 magnitude earthquake happened in March last year, and within 20 minutes, civil defence authorities issued evacuation notices for very specific parts of the coastline. And the reason why they can do that, as you can see in the animation, the wave energy gets changed by the sea floor. The sea floor causes waves to bounce, reflect, to null each other out or to amplify, so that by the time it hits the coastline, it does very different things. So that's an example of where mapping the seafloor makes a big difference. So I'm going to leave a take-home message right now that it's a sad truth that we know more about the surface of Mars and the Moon than we know about the seafloor of the ocean. And CEBA 2030 and the work of the scientists and the marine professionals within this project hope to change that fact by the year 2030. Thank you very much.
Thank you, Kevin Mackay, for that useful introduction to a subject we need to know a lot more about. Thank you very much. And interesting to see that so much of it is going to be mapped in what seems to me a relatively short time, given the expanse of ocean seabed that you have to monitor. Lastly, it's a great pleasure to interview Jean Jouzel, I mean, that's the end, sorry, of our tour du monde, of our world tour of ocean science. And I think you'll agree that that was a pretty interesting set of areas that everybody is working in to look at what's happening to the oceans and to work out how to protect them further. But now we're going to turn to Jean Jouzel, who's a veteran paleoclimatologist, and he's been involved for many years in climate science. And I think you're going to give us a bit of the long view, if you like, or your vision of the ocean and ocean sciences in the global context that we are in today. Jean Jouzel.
Thanks, Victor. Thanks to François Houllier, to IFREMER, to CNRS, and all institutions involved in this forum, and also all individuals who are at its origin and who are active here. As you just told, Victor, I am a scientist, but not at all in the field of ocean science. My field of expertise is paleoclimate, reconstruction of past climate from ice core from polar regions, Greenland and Antarctica. And it is through this past climate change that I became acquainted with the ocean, which indeed is a key player in the evolution of our climate in the past. This applies in particular to the last million years, characterized by large glacial, interglacial changes. And I will give here only a few examples. First one, the change in carbon dioxide in atmospheric concentration with lower value during glacial than during interglacial period. This was evidenced over the last 800,000 years, is largely influenced by change in ocean productivity and circulation. Change in oceanic circulation are also, in this case, linked with the injection of fresh water due to the melting of icebergs in the North Atlantic. They are indeed associated with change in the atmospheric circulation at the origin of very rapid temperature change recorded in Greenland ice cores, up to, or even more than to 10 degrees C in a few decades. This was a big surprise in the 90s. Third example about sea level rise. We have large sea level change up to 120 meters. They have taken place over the last climatic cycles. And it is thus extremely interesting to understand how they occurred, the role of melting of ice sheet in the context of sea level rise associated with current and future global warming. In turn, it is really through its major role in our past, and also because of its strong link with the polar region I am familiar with, both north and south, that I have understood how this unique ocean is important for our today life and for our future. I fully share the view of Thomas Pesquet, of one unique and largely unknown and unexplored ocean, that we know so little about it, that we should take ocean exploration as seriously as space exploration, and that we cannot fight climate change and loss of biodiversity without taking into account the interconnectivity of the ocean, the climate, and the biodiversity. Since 2001, I have participated to all climate conferences, the well-known Conference of Parties. Indeed, these annual highly visible meetings largely ignore the ocean until 2015, as told by Lorelei. It is only since the Paris Agreement that its key role has been seriously taken into account. As you expressed, Lorelei, the situation has improved largely thanks to the mobilization of the ocean community. The ocean is mentioned in the preamble of the Glasgow Pact, noting the importance of ensuring the integrity of all ecosystems, including forest, the ocean, on the cryosphere. This is a real step forward which reinforces the recognition of the intangible link between the ocean, climate, and biodiversity, and the need to address them jointly in international climate and biodiversity processes. Still, you mentioned, but there is often a lack of interest for ocean-based solutions applied to climate change mitigation and adaptation. This concerns, for example, the potential of the ocean to contribute to the development of renewable energy. It also includes conservation measures which can protect carbon-rich coastal ecosystems from direct human disturbance and loss, and play an important role in limiting local climate impacts. The ocean research community has also been mobilized through the successive IPCC reports, in particular for the special report on the ocean and cryosphere adopted in 2019. You also mentioned it, Lorelei. The role of IPCC is not to make recommendations neither to policymakers nor to scientific community, but the need for more research on the functioning of the ocean and its evolution in a warming world is clearly illustrated in this special report. And generally, identification of climate research priorities at the international level largely benefit from the IPCC reports. We have just had the opportunity in the tour of different fields of research to hear about extremely interesting projects developed all around the world. Biomolecular evolution, ocean circulation, pollution, seafloor, use of the sound to detect glacial melting, ocean resources, blue economy, but also risk associated with sea level rise, and even more. At the national level, I fully adhere to the priorities just presented by Catherine Jandel and UNECHIN, and defined in the new Ocean and Climate Priorities Research Program. Its aim is to organize French research with the goal of improving our understanding of the ocean ecosystem and better protecting it. Impacts of climate change, related extreme weather events in overseas France, research in the polar region, characterization of the ocean exposome in order to protect marine ecosystems, innovative observation and modeling programs, improvement of the protection and resilience of marine environment, ocean resources, involvement of the society and of the general public are at the heart of this new and ambitious program. As far as I am concerned, I would like to point out the importance of ocean modeling in the frame of developing Earth and Earth system models in conjunction with observation from ships and in situ, but also from space. Critical questions have to be answered about the emergence and consequences of marine heat wave, about oceanic circulation, including its stability in the North Atlantic, this was mentioned, about the link between ocean state and extreme events, the evolution of El Niño in a warmer world is not really well known, the problem of acidification and desoxygenation of the ocean, reaction of coral reefs under the pressure of ocean warming and of acidification, about the evolution of the ocean carbon sink, which indeed is predicted to be smaller with higher carbon dioxide levels, and many more questions about biodiversity, pollution, resources and habitat degradation, or more generally about ocean health. To conclude, I will simply come back to the opening of this One Ocean Science Forum. It is crucial, I take these words from the introduction, it is crucial to build the most reliable source of knowledge to fight climate change because without science there is no future. This fully applies to our ocean.
Thank you very much indeed, Jean Jouzel. So without science there is no future is definitely a message we should take home, and we should all be listening much more to the scientists. Those of us who are not scientists should be listening, I think, with greater attention to the scientists that we've heard from today. Just before we close, we have a guest from Gabon. Arlette Soudan Nono, I think, is here with us. Here you are. Come. No, that's fine. We can do it in French. Thank you very much for being with us. Pardon, j'ai été mal informé. Excusez-moi. I'm sorry. I got the country completely wrong. From Congo, Brazzaville. Apologies for that. Your English is excellent, but she's going to speak in French because she prefers that. Just tell us a little bit about the issues for you in Africa, and particularly, I think you're the coordinator of the Congo Basin Commission for Climate Change. Is that correct?
Yeah.
Donc, comment vous voyez les choses? You're going to do this in French.
Voilà, tout à fait. Je suis ministre de l'Environnement, du Développement durable du bassin du Congo, mais en même temps coordinatrice technique de la Commission climat du bassin du Congo. Le bassin du Congo, deuxième poumon écologique de la planète, en passe d'être le premier en termes de régulation du climat et qui abrite également 10% de la biodiversité mondiale. Et donc aujourd'hui, nous avons, mon pays, la République du Congo particulièrement, nous avons 170 km de côtes que nous préservons au travers des aires protégées marines. Nous avons également maintenant une démarche qui met en place l'état de l'action de l'État en mer, en fin de compte, avec un commissariat. Mais j'aimerais peut-être, au-delà de tout ce que nous disons, au-delà de toute la démarche déclarative, de cette bonne volonté, surtout de ce excellent travail qui est fait par les scientifiques, moi j'aimerais peut-être attirer l'attention des politiques et des hommes publics qui nous sommes. Au-delà de
accomplished by scientists. I'd like to really draw politicians' attention to the fact that political will is not enough. I think we need a legal framework
to par continent,
have a
par
legislation
État, que les décisions se prennent. C'est ça la
instead
que nous avons.
of
Nous ne
taking
parlons pas le même
decisions
langage, en fin de compte. Nous n'avons pas les
continent
mêmes
by
priorités.
continent,
Et pourtant,
on a
il n'y a
country
qu'une
by
seule planète. Et pourtant,
country
il n'y a
by
qu'une seule
country,
ressource en nous.
because
Merci
there's
beaucoup.
just
Et
one
quels sont les
planet
enjeux,
and
surtout pour les
there's
océans?
only one water resources. And what is at stake, what are the challenges mostly for oceans? You've talked about efforts being undertaken to protect the coasts. And how do you see things for oceans? Overfishing? Well, we have a big problem as far as oceans are concerned, because being dependent on satellites, we have people fishing in overfishing in protected areas and threatening fish resources. So I think we need to sit down and make decisions and take and also develop a national legislation on that. But that's not enough. We find it difficult to circumscribe the surface of the ocean around the planet. So in addition to overfishing, another problem is pollution, non-biodegradable materials like plastics coming back to our coasts. And those powers which often put us southern countries in difficulties, and we have to restore those areas which have been polluted. We have people in our countries living from those methods, from fishing and from those artisanal methods. I think we should not just come, reflect at political level. That's why I traveled from Brazzaville to Brest. I think we should really be able to do something about it, even for those countries which are members of the Guinea Gulf. We need to do something. Well, thank you very much. It's very kind of you to come, and that is why scientists are explaining everything they're trying to do to solve those problems. Thank you very much, Alex Soudantono from Congo-Brazzaville.
End the session. Thank you very much for that. I think we're now going to turn back to François Houllier, who's going to bring us to a close at the end of this forum. Thank you very much.
Thank you, Victor. First of all, I would like to really warmly thank the different participants and those who took part to this world tour, especially those who spoke from far away. Some of them were at night. So thank you very much to your contribution. I think one of the ideas that we had in the title One Ocean Science, of course, it's one ocean. And I think the minister insisted on this idea of one ocean. That has been also said by many of the participants. It was said by also Thomas Pesquet. So this idea of one ocean, but also of one ocean science. And the idea that although we have tried to show the different facets, the different disciplines, the different topics and different issues that we have to deal with, I think it's important that we recognize that there is only one science with different aspects. I would also like to thank the participants for their creativity, for the innovative approaches that some of them have provided. I think all of us learned something. Of course, it's only 10 countries, only 10 scientists, so many more of them do exist in the world, but I think it's important. Tomorrow there will be a workshop that has been organized by this for this One Ocean Summit that is mainly organized by UNESCO. This is a workshop that is called the Science We Need for the Ocean We Want. I'm supposed to say a few words at this workshop, so I hope I will be up to the task of for conveying your creativity, innovation, capability of doing new things and learning more on the ocean. I will try to convey that message tomorrow. I will also try to convey the message of the first forum, which was about the coordination of the fleet. So with that, I would like to close and again thank the participants. I also would like to thank my colleagues who organized that, to thank you especially, Victor, for moderating our talks, and also with a special thought for Geraldine Guillevic, who has been very instrumental in discussing with all the participants and preparing everything. She has the COVID, so she couldn't be with us today, but thank you to all of you.
Yes, thank you, François. Thank you, Geraldine. Thank you to Ifremer, and thank you particularly to all the scientists who took part, sometimes, as François said, from very inconvenient time zones. And thank you all for listening and for watching. And let's look after the ocean better than we have done so far. Thank you very much.